Boom. And we'll go ahead and get started. So, of course, chapter 3 of volume 1. And of course, we're still in part 1, going over the fundamentals. We just finished talking about the core of WAN technologies from a fundamental standpoint. The last thing we need to speak about of chapter 3, this is going to be a short session, by the way, today. We're just going to touch on the other network layer features, okay? And, and how they work with one another, right? And we're going to touch on 3 things, right? DNS, ARP being my favorite protocol, just because it helped me close a lot of cases whenever I was working as a tech engineer at Cisco, and ping, okay? And so some of you guys probably know what DNS is. Some of you guys probably don't. So let's go ahead and touch on it, right? So imagine, right? Let's close our eyes and imagine, us being in a world to where we can't just go to google.com or gamestop.com or twitter.com, right? We would have to go to each resource or site that we want to access by IP address. Come on. That's ridiculous. That'll be entirely too much for everybody to remember. It'll be just like our grandparents or parents, hopefully they're still not doing this, writing down all their passwords and putting it on a fridge. That's how we would try to keep track of how we would access certain resources in a site, right? So what do they do, right? What did these organizations, the IEEE, the IETF, and all these other big organizations, and these engineers that work within them create, right? To make everybody's life easier, right? To connect better, more efficiently, what have you. They created, this technology called DNS, right? Domain name system, right? And it does exactly the reverse of what I just explained, right? If Gil is trying to get to google.com, right? Gil is just putting in his browser google.com in the background, right? DNS and the network layers working together, right? Layer 3 is saying, okay, let me go ahead and reach out to my DNS server and see who google.com belongs to, what's the actual IP address, right? Because layer 3 works based on IP addresses, right? It only is worried about the source and the destination. So, but it needs to work with DNS to try to understand, hey, what is my destination? Because I don't know what google.com is, right? Luckily, they work together and they go ahead and say, hey, there's this big database, right, in this server that knows how to get to anywhere, right? And if it doesn't, there's specific micro technologies within the technology that says, hey, I know, if I don't know where to get somewhere, I know how to find a way to get somewhere, right? And so that's how typically it works, right? That's how DNS works. And we use it each and every day. This is just the insides of it, right? So let's go ahead and talk about this diagram real quick. Let me go ahead and get my handy dandy pen. I feel like using green today. So again, we got Gil's PC, right? PC 11, right? He's trying to get to server 1, right? And that DNS server is responding, hey, I know what server 1 is. That IP address is 10.1.2.3. Let me go ahead and send this back down to Gil's PC so that I can go ahead and properly go ahead and construct that packet, right? Because we're still talking about layer 3, so that I can then go on to layer 2 and construct a frame, put a header and a trailer, right? And then put it on the wire, right? Because Gil's PC cannot do anything, or any of our PCs cannot do anything unless it knows the destination, right? Or if there's no way to find out the destination of where he's trying to get to, right? So this is high-level overview, high-level explanation, David's explanation of what DNS is, right? And how it works. Simple enough. Any questions? Okay. All right. So I'll keep going. Let me go ahead and put this away. Now, my favorite protocol, address resolution protocol. Can anybody, you know what? I'm not going to leave it open-ended. Cornelius, can you tell me what ARP is? Take a guess.
It's mapping IP. I mean, MAC addresses to MAC addresses to IP addresses.
Boom. That's it. That's it. Right. So thank you, Cornelius. So to go ahead and go a little bit further than that, right? So it's exactly what Cornelius said, right? But you guys are probably wondering, right? Okay, can a switch do that? Can a router do this? ARP is typically used from, if we're looking at a CCNA, right? Layer 3, we just think about routers, okay? A router does not have a MAC address table, right? So how do they go ahead and know, you know, what, IP address belongs to which MAC so they can go ahead and um, build a packet you go ahead and send on a wire, right? They have the ARP table, right? ARP typically lives at layer 3, right? It's in the middle, right? It's a protocol that lives in the middle of layer 2 and layer 3, but it's a great protocol, right? So it can go ahead and map IP addresses to MAC addresses, okay? And so let's say, right, we're looking at this, right? We're looking at this diagram. Let me go ahead and get my pen. Use a different color. There's too much red in there. Okay, so Cornelius's PC, IP address 150.150.4.10, right? And so his MAC address is of course, 0200.22222.22222, right? And so, right, we have the layer 3 information, right? He's trying to go ahead and he's trying to get to somewhere, right? He's trying to get to whomever, right? But he needs to understand where he needs to send it to from a layer 2 perspective, right? So yeah, he'll have the IP address of maybe the router or maybe Google, right? But he needs to understand, and we'll just say the router for this case, he needs to understand what the MAC address of this Ethernet port is, right? And so that ARP table is going to say that lives on, it can either live on his PC, and there's, of course, there's an ARP table that can live on that router that says, hey, this IP address maps to, cool, this MAC address, right? And R3's IP address should map to R3's MAC address. That's all the ARP table does, right? And so as you guys can see in that diagram, if we look at this note section, right? And you guys can try it on your own PC, pull up a command prompt, right? This is based on Windows. You can go ahead and type in ARP-A. You can actually see an ARP table on your Windows PC, right? See all the mappings or what have you, right? And so how that traffic flow works, and we'll have a session to where I'm in my home lab and I can show you guys the Wireshark. Well, matter of fact, I can go ahead and show you, pull down I can actually pull down a example packet capture off the web. So we'll do that at the end. Somebody please remind me. And so typically, again, you have two packet types in how the flow of ARP works. We have an ARP request. We have an ARP reply. Okay. And so I'm going to go ahead and clear that out real quick, right? And so notice the type of frame that's sent out, type of packet that's sent out, right? So ARP request is a broadcast, right? It's screaming out on the entire local area network that it's on, right? Who is this IP address, right? And in that reply, it's going to respond with its MAC address, right? But it's not going to be a broadcast. It's going to be a unicast, right? For example, all of us in this room, if I say, who is Cornelius? Cornelius is going to be the only one that responds. Okay? He's going to tell me his last name, and that's it. I'm going to know how he looks. Boom. Address resolution protocol. Does that make sense? Again, high level, we're going to look at the technical piece whenever I pull up those packet captures. Any questions? Okay. All right. So I'll take it as enough. So I'll go ahead and keep going. Go ahead and pop to the last slide. Whoops. And that is the wrong one. Give me 1 second, guys. Let me edit this. Give me 1 second. All right, everybody can see my screen? All good? Okay, cool. Take that as a yes. So had to edit that slide. I saw it was showing the ARP screenshot on the ICMP slide. So I went ahead and fixed it. So, right? So one of the probably one of the most important mechanisms in the TCP/IP suite is ICMP echo, aka ping, right? And I'm sure you guys use it more frequently than none, right? And ping stands for packet internet grouper, right? Right, and ping uses, right? And just to this is going to get a little bit technical. Ping uses ICMP, right, to send that ping, right, to send those requests to say, hey, other IP address, are you alive, right? And the other IP address is going to respond back saying, hey, I am alive, right? And here's my reply. Okay. And so typically there's going to be output that comes on a computer that says, hey, it's alive or what have you, right? And we can actually do it here. Let me go ahead and pull up this, right? Let's say I want to ping Google, right? I'm getting a reply. I'm getting those echo replies back, right? So I'm using the ping command, the packet internet grouper, right? And it's using, right, ICMP to go ahead and send those request packets from my computer, and my destination should respond back with a reply, right? And this is a mechanism that's built into the TCP/IP suite. Okay, so really simple, doesn't really rely on the application. ICMP is it's really agnostic to any of the other layers, right? It sits right on layer 3, right? But it's by itself, how it works, right? And where it's located. Okay. And on that note, that's it. That is part 1. All right. Let me go ahead and pull over a couple of things I want you guys to knock out before we go over to part 2, right? So within the CCNA book, not sure if you guys have the physical version or the ebook, right? All the rules apply, right? Um, do review, keep track of your progress if you really want to be adamant and have a higher success rate of passing the CCNA. Please follow all these review portions. They actually tell you to go over the questions that start at the beginning of the chapter, repeat all the do I know it already questions, dicta, if that's how you say it. I kind of hate acronyms, but hey, you go over those questions at the beginning of each chapter, right? Answer the part review questions, right? And that's actually at the end of the chapter, um, end of each chapter. Go over the key topics, right? And use the per chapter interactive review elements, right? And that's within the chapter to go ahead and make sure that you know what you're talking about, you understand what this information that you're getting from the book is giving you, so that you can move on to part 2. Because again, all of this is foundational to the next step, right? Or the next level of that knowledge, right? And if something doesn't make sense, again, you have resources, reach out to me. You have Google Food that you guys, I know you can use. There's YouTube videos. And if I don't know something and does not explain something clearly for you guys, um, feel free to, of course, look at other resources. And I have also no problem responding back to you guys saying, hey, Dave, thanks for explaining to it, but it still doesn't make sense. I will provide you other resources and people you can talk to that could probably explain it better than I can. Okay. Um, and hopefully that makes sense. Last but not least, let me go ahead and show you guys this packet capture of ARP, DNS, and we can do ICMP so it can all make sense and you guys can actually see it. Capture ARP example. There we go. Let me actually show you guys this site. I've actually used this to pass my CCNP and other examples because when I didn't have a lab or have Wireshark and etc., I had to use this to actually understand what's going on in the background. Okay, so let's go ahead and take a look at our ARP PCAP. Let's go ahead and pull this up. Boom. Allow me later. Let's go ahead and do a filter. There we go. All right. So I filtered by the ARP protocol right here. All right. And let's take a look at how it looks. Okay. Boom. Right. And so let's go ahead and break this down. Right. So if we're looking at ARP, right, you see that it's not being sent by layer 3. It's being sent by layer 2. Right. But in the request, right, it's saying, hey, who has 10.0.0.2, who has a specific IP address, and tell, right, the source that's sending it. Okay. And so they're going to communicate, right? They're going to communicate at layer 2, right? Based on layer 3 using the ARP protocol, right? Because it's its own protocol. And that's how it's going to know where to send it. Okay. So hopefully that makes sense. And again, I love looking at these packet captures because it honestly, reading the book, um, honestly, that shit is confusing. Excuse my language. And it's a lot of information. So taking a break, looking at actually how stuff transpires on the wire, it actually makes sense. Okay. And I'll post this. I'll go ahead and post this in the chat so you guys can pull it down. You guys can see it in the Zoom chat. Okay. Let's go ahead and take a look at see if we can see PCAPs on DNS. Give me 1 second. I should have a browser protocol, DNS. Let's take a look at DNS. There we go. All right, all right, all right. There we go. Question and answer. That's what I need to look for. Go ahead and pop open. Okay. All right. All right. All right. So let's break this down. There we go. All right. So we have this PCAP, right? We have the source, right? Tell you everything. Source for anything layer 3, we have a source and destination. Okay. So the source 192.168.1.52, that is a private IP address within RFC 1918. We'll go over that in the future, right? So once you guys get used to looking at these IP addresses, you'll see, hey, that's an IP address that's on a local area network that's within a network. So it's not actually a IP address on the web. So it's making a request out to 8.8.8.8, google.com. Okay. And so we can see, right, it's sending it to Google, right? And it's sending a query, right? Trying to understand, hey, who is google.com, what have you, right? And it responds back saying to that with a response, right? With answers. Hey, google.com can be any of these IP addresses. Okay. So again, the source is going to go ahead and send a DNS query. That destination, right, is going to go ahead and respond with answers, right? So that DNS server is responding back with a whole bunch of answers, right? Where it lives, right? And where it can go to, okay? Does that make sense? Okay.
Yeah, it makes sense.
Last but not least, let's go ahead and take a look at a ping. Okay. Yeah. Let's take a look. We have a regular ping. That's not actually what I want. That's not what I want. Let me. Nope, that's not what I want. Yeah, example. Nope. Okay, let's see if I can find something. Okay, let's try with this. See what this looks like. Okay, let me do this. No. There we go. But it's only showing one way. Okay, hold on. Let me let's take a look. Let's take a look at this. There we go. All right. So, real simple. ICMP, right? And we don't have to blow this up, right? We see our request and we see our reply, right? We see our source 10.0.0.1 and our destination 10.0.0.2, right? So our source .1 sending that request, .2 sending that reply, right? And so here's the second one, here's the third one, here's the fourth one, here's the fifth one, right? And we should have 5 replies as well. Okay. And that's it. Does that make sense, guys? All good? All minds and hearts are clear? Okay, I'll take that as a yes. Guys, the recording will be posted shortly. And tomorrow we are going to have a fun lab day where we go over, we're going to be doing some of the stuff in a lab, combining everything that we've done so far in part 1. We're going to do a lab tomorrow and we're going to do a lab Thursday. Then come next week, you guys are going to have a good break because so there's going to be no sessions next week. Then, of course, at the end of April, what's going to happen is you guys are going to jump into part 2, and that's when we're going to start talking about the nitty gritty, doing some show commands, diving into some switches, going over some real in-depth theories. Okay. All right, guys. Well, you guys have a good day. Thanks for joining.
Thank you, David.
Thank you,
Thank you, sir.